Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. Today I am going to deliver a lecture on subject of control system engineering. In this video, I will be explaining problems on block diagram prediction. This is unit second topic of 6th semester in electrical engineering branch. Consider the block diagram. So in figure, let's we simplify this block diagram using block diagram reduction technique. In the first step, we use rule 1 and rule 2. We can see here these both blocks are in series. So if there is two blocks are in series, then the resultant of block diagram reduction is G1 into G2. We can multiply both the gain if there is two blocks are in series. And we can see that here G4 block and G3 block are in parallel combination. So here if we use block diagram reduction technique, then our answer will come G4 plus G3 because in parallel we add the both block, because here we use summer. It's summing the both gains value. So now our figure means our block diagram is looking like this. In the second step, use rule 3 for the block G1 G2 and use rule 4 for shifting takeoff point after the block G5. So we can see here this making a loop. This is gain G and this is the feedback H. If we apply for this feedback formula, we know that the feedback formula is gain upon 1 plus G into H, gain into feedback path. Here the gain is G1 into G2. So we can write G1 into G2 upon 1 plus G1 G2 into here is feedback is H1. So the resultant for this loop is G1 into G2 upon 1 plus G1 into G2 into H1. And we can see here. And if we move and if we take this takeoff point from here to here, we know that according to the block diagram reduction, in the feedback path of this takeoff point, here we can multiply 1 over G5 according to the block diagram reduction technique. So now our block diagram is looking like this. H2. Now the feedback gain for the next loop become H2 over Z5. Now we can see here again these blocks are in series, so we will multiply both the gain of these blocks. After that our circuit become like this. Now we can say that here also a feedback path and feedback loop. We apply again the formula of feedback loop. Here the gain is G3 plus G4 into G5. G3 plus G4 into G5. This is gain. And 1 plus and feedback is here is S3. So S3 into G3 plus G4 into G5. If we put this value for this block, we can say our block modify by this. Now we also see here again two blocks are in series. So again we multiply both the gains of these two blocks. After that our block modify by this figure. We can see here the gain for the next block is G1 G2 into G5 into G3 plus G4 upon 1 plus G1 G2 H1 and 1 plus G3 plus G4 into G5 into H3. And here the feedback path gain is S2 over G5. We can see that here again this is the again a loop at which the gain G is this and feedback is S2 over G5. So again we apply the formula of feedback loop G over 1 plus G into H. Here the feedback is positive feedback. So if we apply this formula for this, we know that in positive feedback here the formula becomes G over 1 minus H into GH. So after calculating it, we can obtain the value of this is G1 into G2 into G5 square into G3 plus G4 upon 1 plus G1 into G2 into H1 and 1 plus G3 plus G4 G5 H3 G5 minus G1 G2 G5 into G3 plus G4 into H2. So this is the value of our transfer function ys over xs. So by using the block diagram reduction technique, we can solve the transfer function by this. So the transfer function ys upon rs for the system is this. Now solve the second circuit. Here you can see that us is the input for the circuit and ys is the output for the circuit. Now we can see that here is a loop which gain G1 and second block gain is G3. Now if we apply here the formula of feedback loop G over 1 plus G into H, we can see here the system will be modified like this. G1 over 1 plus G1 into G3. And here we can see that here is also a takeoff point. So we want to move this takeoff point from here to here, means after the block of G5. So according to the block diagram reduction, if we move takeoff point after this block here in the feedback path of this gain, here one gain is divided here G5 divided by G5, okay, of this is the gain of that block, after which we move the takeoff point. So if we apply this rule, means the takeoff point is moved across the block by dividing by G4 in the feedback loop. Now the three blocks in the forward loop can be combined together and make the circuit like this. So we can see here these three gains are in series, means these three blocks are in series. So we multiply these gains. If we multiply these gains, our system modify like this. Here the value, total value is G1 into G2 into G5 upon 1 plus G1 into G3. And this is input and this is output, or we can say this is feedback path. And the gain of feedback path is G4 upon H5. So we can say that we can see here also there is a loop, feedback loop. So we apply the formula of feedback loop and we can see that here is a negative feedback loop. So if we apply the formula G over 1 plus GH, because we use here negative feedback loop, then the gain of system become G1 into G2 into G5 upon 1 plus G1 into G3 plus 1 plus G1 into G2 into G4. So this is the overall gain of block, and we can say that this is the transfer function for this block, and we simplify the complex block in the simple manner. Hope you understood this topic better. Now the second example is, here we can see that this is input for the block and this is output for the block, and here is two blocks are here. In the gain of the first block is G1 over 1 plus G1 into H1, and the gain of the second block is G2 over 1 plus G2 into H2, and here is also a feedback path at which the gain is H3. So now you can see that here two blocks are in series, and we know that in series combination, if there is two block G1 and G2 are in series, then if we want to combine this block into a one block, then we multiply the gain of both blocks, it will G1 into G2, and after multiplying the both gains of this block, the value for this one block is G1 into G2 upon 1 plus G1 into H1 into 1 plus G2 into H2. And here is feedback loop, and the gain of feedback loop is S3. So for this block we can simplify this block by applying feedback formula, and here the feedback is negative, so we apply the formula G over 1 plus G into H. Here G is the gain of this block and H is the feedback of this block. And after putting these value in this formula, we can get the value for next block is G1 into G2 over 1 plus G1 into H1 plus G2 into H2 plus G1 H3 G2 plus G1 G2 H1 H2, and this is the input for the block and this is the output for the block. If we want to calculate the transfer function, we know that what is transfer function? The transfer function is the ratio of output Laplace transform to the input Laplace transform. This is in the frequency domain. Okay, if we calculate the ratio of output to input, the value of this transfer function is this. So by the block diagram reduction technique, we can simplify these blocks in the simple block. Where we use block diagram technique, reduction technique, we know that in control system many system is represented by the blocks. So if there is many component represented by the blocks, then we have to need to find out the transfer function. For calculating this transfer function, then you can reduce these diagram for the to the simple diagram. For this you are using block diagram reduction technique. So by this we can find out the overall gain or transfer function easily for any complex block. But we need to follow some rules. Which rules? These rules which are used for block diagram reduction technique. So here today we had seen how we can apply the block diagram technique for solving this complex circuit. Thank you.